Hi everyone, my name is Pat Barrett and I work in the Water Management Program of the EPA. My presentation today will provide a summary of the methodologies that would be used by the EPA to assess the impact of abstractions on water bodies and to determine if the abstractions are significant abstractions. Just to reiterate, the significant abstraction assessments will be undertaken for abstractions between 25 meter cube per day and less than 2000 meter cube per day. Very quickly, just to give an overview of this presentation. Firstly, I'll draw your attention to the significant abstraction guidance that the EPA have produced. I'll define what a significant abstraction is as per the legislation, and then discuss the various assessment methodologies that will be undertaken, which include the river water body assessment, the lake water body assessment, groundwater body assessment, and the associated impoundment assessment. So to draw your attention to the guidance, EPA have produced guidance which details the methodology and hydrological limits used for identifying significant abstractions in Ireland. And essentially this presentation is an overview or a summary of the information contained within that guidance. In March 2025, EPA undertook a 3-week public consultation. And following that, a final guidance document has been produced and will be published on the EPA website in the coming weeks. So what is a significant abstraction? The text on this slide is taken from the Act and provides a detailed definition. And essentially, the overall objective is that abstractions don't compromise the environmental objectives for rivers, lakes, and groundwater, and the flora and fauna of designated water-dependent European sites. So how are significant abstractions identified and assessed? Well, depending on the abstraction type, a number of assessments take place, one or more of the following: river water body assessment, lake water body assessment, the assessment of groundwater bodies, and in cases where the surface water abstraction is dependent on an impoundment, an assessment of the associated impoundment will take place. And for the remainder of this presentation, I'm going to describe each of these assessments in detail, beginning with the river water body assessment. So the river water body assessment is undertaken to determine whether adequate flow or environmental flow is being maintained in the water body and associated protected areas to support and maintain healthy ecology. In the context of the WFD, this refers to a hydrological regime consistent with the achievement of the environmental objectives of the WFD in natural surface water bodies, as mentioned in Article 4. So overall, the methodology takes a cumulative catchment-based approach and considers the residual impact of abstractions on downstream water bodies. For example, a lake abstraction can cause flow reductions in downstream rivers. So our assessment takes account of this potential impact. Within the river water body assessment, there are 3 steps. Number 1, the application of hydrological limits. So within a catchment, does the cumulative impact of all abstractions cause a breach of hydrological limits in any river water body? If the answer to that is yes, spatial analysis assessment takes place. Is the breach happening in more than 5% or 15% in higher good status objective water bodies respectively of the length of any river water body? If the answer to that question is yes, step 3 is undertaken, which is referred to as the 1% rule. Are any individual abstractions between 25 and 1999 meter cube per day taking more than 1% of the volume of water which can be sustainably abstracted from an individual river water body? If the answer to that question is yes, then the contributing abstractions are considered to be significant abstractions. And I will delve a little bit deeper into each of these steps now. So step 1, hydrological limits. Within a catchment, does the cumulative impact of all abstractions cause a breach of hydrological limits in any river water body? So the river flow limits, which are detailed in the 2 tables on the left, are flow duration curve-based limits, which allow for a given percentage of the flow to be abstracted at various naturalized flow percentiles, When we refer to flow percentiles, for example, Q95, this is the flow that is exceeded 95% of the time. The specific allowable abstraction, so the numbers within these tables, is dependent on the river type. And the river types in Ireland are shown on the map on the right. The top table details the river flow limits for high status objective river water bodies, and on the bottom are the river flow limits for good status objective river water bodies. And if we stay on step one, hydrological limits, and we look at this conceptually, the image on the top shows a river water body. The black outline is the boundary. And on the bottom, I will show a graph here, and the bottom axis along the bottom is the distance from the top of the catchment to the bottom, from left to right, and the water volume is shown on the left. The blue line here shows the increasing Q95 flow from the top of the catchment to the bottom. So Q95, this is low flow conditions. And the green line shows the environmental flow, or the E flow. And this is calculated based on the river flow limits in the tables on the previous slide. The difference between the naturalized Q95 flow and the environmental flow, this is the water that can sustainably be abstracted. Then if we take account of abstractions in the river water body and discharges in the river water body, we can establish what the influenced flow is, what's really happening in this river water body. And from this, we can see that in this river stretch highlighted in red, the E flow limits, the hydrological limits, are being breached. So in this river section, too much water is being abstracted. So we move on to step two, spatial analysis. So if we take this water body to be a high status objective water body, the question we ask is the breach happening in more than 5% of the length of the river water body? And based on our calculations, we can say that it is. So we move on to step three, which is the 1% rule. In this step, the question we're asking is, are any individual abstractions contributing to the breach in hydrological limits, taking more than 1% of the volume of water which can be sustainably abstracted from the water body? The volume of water which can sustainably be abstracted is shown on the graph on this slide, and it's the difference between the naturalized flow in blue and the environmental flow in green. And essentially, if an abstraction that's between 25 and less than 2000 that fails the hydrological limits in step one and the spatial analysis in step two, they will be identified as a significant abstraction where the volume that's being abstracted is greater than 1% of the volume of water that can sustainably be abstracted from the river. If the abstractions are less than 1% of the volume of water that can sustainably be abstracted, they will not be considered significant abstractions. So that's the river water body assessment. So just to summarize very quickly, there's three steps: the hydrological limits, the spatial analysis, and the 1% rule. So now I'm going to move on to the lake water body assessment. And essentially, water abstractions in and or upstream of a lake water body may alter the natural range of water level fluctuations, which in turn can impact lake ecosystem dynamics and ecological health. So the lake water body assessment assesses changes to the littoral zone, and the littoral zone is the shallow water habitat through which sunlight can penetrate to the lake bed, and that's shown as an example in the photo on the right. This area is important ecologically because it supports rooted plants, macrophytes, and other biotic species. So the assessment that we undertake here focuses on this important area of the lake. In terms of limits, do abstractions within the lake and or upstream of the lake reduce a lake's habitable zone, which is the littoral zone, by more than 1% in high status lakes, or 5% in good status objective lakes for more than 1% of the time, which equates to 4 days per year? In some cases, the data sets required to undertake that assessment may not exist, for example, bathymetry data or water clarity information, and if so, an alternative approach is used, which is essentially, is the volume abstracted greater than 10% of the Q50 lake outflow? In either case, if the conditions are breached, these abstractions, the contributing abstractions, are significant abstractions. So that's the lake water body assessment. We have our methodology. If data sets don't exist, we have an alternative approach. Okay, so moving on to the groundwater body assessment. Groundwater abstractions, so either alone or in combination with other abstractions, can directly impact groundwater resources. And this can lead to an unsustainable lowering of groundwater levels, or due to different quality groundwater, for example, saline waters being introduced. Groundwater abstractions can also indirectly impact surface water resources, which may alter the supporting conditions needed to sustain a healthy ecology in surface waters and groundwater dependent wetlands. There are 4 tests that are considered within the groundwater body assessment, and these have been in use in Ireland for several years as part of the Water Framework Directive assessments, and these are detailed in full in EPA publication that's available on the EPA website. The 4 tests are the groundwater body water balance test, the presence of saline or other intrusions, the impact on surface water bodies, and the impact on supporting conditions of groundwater dependent terrestrial ecosystems. And the next number of slides, I will go into each of these tests in detail. So firstly, the water balance test. Groundwater recharge, just to summarize initially, groundwater recharge is water that percolates through the soil and subsoil and replenishes groundwater stored in an aquifer. Where groundwater is being abstracted from a groundwater body via a well or borehole, it is important that the volume of groundwater abstracted over a prolonged period does not exceed the long-term annual average recharge to the groundwater body. And this is to ensure that sufficient groundwater resources remain in the aquifer to support other water uses and the wider environment. So we have a number of rules that we apply to ensure that this potential impact is addressed. Firstly, an abstraction is identified as a significant abstraction where the cumulative volume of water abstracted from the groundwater body is greater than 80% of the average groundwater recharge of any groundwater body. Then, an abstraction is identified as a significant abstraction where there is evidence of falling groundwater levels due to abstractions, and the cumulative volume of water abstracted from the groundwater body is greater than 5% of the average groundwater recharge of the groundwater bodies supporting a GWDTE, 20% of the average groundwater recharge of bedrock groundwater bodies, and 30% of recharge of gravel groundwater bodies. If breached, the contributing abstractions are considered significant abstractions. The next test is the saline or other intrusions test. So where the water balance test flags an issue, a water quality check is carried out to see if there is also saline or other intrusions occurring in the groundwater body. Saline or other intrusions can occur when the saline freshwater interface in coastal regions is drawn inland and upwards by an abstraction. Groundwater abstraction can also lead to upward movement, also known as upconing, of poor quality water, the leakage of saline surface waters to an underlying groundwater body, or drawing in of poor quality groundwater from an adjacent aquifer. This assessment determines if the abstraction is causing an exceedance of the groundwater threshold value and has caused sustained upward trends for electrical conductivity, chloride, or sulfate concentrations in groundwater. If breached, these abstractions are significant abstractions. The next test is the impact, assessing the impact of the groundwater abstractions on surface water bodies. So stream flow depletion is the reduction in stream flow in rivers or streams that occurs when groundwater base flow, so groundwater inputs to streams, is intercepted by groundwater abstractions. In some cases, groundwater abstractions can draw water from the stream itself. So we apply a risk-based approach here. Initially, we undertake screening. Groundwater abstractions are unlikely to pose a risk to rivers when the abstraction is less than 100 meter cubed a day from poorly productive aquifers with low to moderate vulnerability, less than 250 meter cubed a day and greater than 150 meters from streams, irrespective of groundwater vulnerability, and finally less than 250 meter cubed per day in karst areas and outside the zone of contribution to springs. So abstractions that meet this criteria are not significant abstractions, but for the remaining groundwater abstractions, the potential stream flow depletion caused by the abstractions should be calculated and considered in the surface water assessment. And essentially, any groundwater abstractions contributing to a breach in the hydrological limits within the river water body assessment are identified as significant abstractions. The final test within the groundwater assessment concerns the groundwater dependent terrestrial ecosystems. GWDTEs are wetlands where the habitats and species are dependent on groundwater levels or flow. And again, we apply a risk-based approach, screening initially. So groundwater abstractions are unlikely to pose a risk to GWDTEs when the abstraction is less than 100 meter cubed a day from poorly productive aquifers with low to moderate vulnerability, less than 100 meter cubed a day, and greater than 250 meters from a GWDTE, irrespective of groundwater vulnerability, and less than 250 meter cubed per day in karst and outside the zone of contribution or trace conduits to the GWDTE. Again, if the abstractions meet this criteria, they are not significant abstractions, and for the remaining groundwater abstractions, the reduction in groundwater levels and flow to the GWDTE should be calculated. And just to note, the links between water level, flow, and ecology are often very complex and are again often wetland specific. Therefore, assessments involving GWDTEs may require the involvement of suitably qualified and experienced ecologists. And essentially, any groundwater abstractions that have reduced the groundwater level or flow to a GWDTE such that the groundwater dependent qualifying interests of the wetland have failed their environmental condition assessment under the Habitats Directive will be identified as a significant abstraction. Okay, so now I'm going to talk about associated impoundments. So an impoundment, as defined by the Act, means the doing of anything whereby the water level or flow in surface waters or the continuity of the morphological condition of a body of surface water is permanently or temporarily changed by means of a structure. An associated impoundment is an impoundment on which an abstraction depends and cannot exist without. So we're concerned with associated impoundments. And it's important to remember that impoundments alter the natural distribution and timing of river flows in natural ecosystems. They may also act as barriers to the movement of sediment and migration of aquatic species. The environmental impact of an associated impoundment will depend on the impoundment design, the function of the impoundment, and the prevailing flow conditions. As such, site-specific assessments are required. Where there is evidence that an abstraction between 25 and less than 2000 meter cubed per day is dependent upon an impounding structure, the abstraction will be identified as a significant abstraction in all cases. This is because the impact of impounding structures on the morphology, hydrology, or continuity of surface waters requires a site-specific assessment to determine if the impounding structure is impacting on the environmental objectives of the surface water body being achieved. And that brings me to the end of my presentation, and I would like to thank everybody for listening, and I'm happy to take any questions that you may have. Thank you very much.